Alrighty, let's have a look at the physics of an Ollie. An Ollie is a skateboarding move where you don't actually grab the skateboard, but you make it leave the ground. It's a way to jump over something that might be in your way. So let's break this down. First up, you crouch down basically just so that you can get a good jump up. The higher you want to Ollie, the bigger your jump is going to need to be. Now, as you're jumping up, and I'll just pause about here, as you jump up, you push down on the back of the skateboard, we call the tail, and you note that I've pushed the tail down onto the ground. My foot has not actually gone all the way to the ground. So you sort of shove the tail down, but you don't stomp on the tail because then it's just going to stay on the ground. What we want to put into play here is Newton's third law of motion. For every action force, there's an equal and opposite reaction force. So we want to shove the tail of the skateboard down into the ground so that it bounces back up off the ground. Okay, so as the tail slams into the ground is going to be slamming back up into the tail, right? Equal and opposite forces. Now, and if we just put our foot down on the tail, well, then we're just standing on the skateboard now. It's not actually bouncing back up into the air. So that's the first point, Newton's third law of motion. We slam the tail back down into the ground, and the ground pushes it back up into the air. And if we play this, there we go, up into the air. Now, the front foot, you'll notice, has slid up towards the front of the skateboard, what we call the nose. Now, as it does that, it's applying a bit of a force on the nose, stopping the nose from coming up. Now, the energy is conserved in this respect, it's rotational energy. So as the front foot is slid up towards the nose of the skateboard, the tail comes up. Let's just go a bit more. There we go. So the skateboard is now fairly horizontal-ish. Okay, so if you just slap down on the tail, the nose is going to come up, and the skateboard will go vertical. By sliding your foot up the board, that keeps the nose down and lets the tail come up. Okay, so we were looking at rotational kinetic energy there, so conserving their energy. And then after this stage, essentially gravity is going to do its thing and pull everything back down to the ground, the skateboard and the person riding it. And then, of course, upon landing, you bend your knees and you straighten up and you roll away. So there we go. That's the physics of doing an Ollie, I guess. It's Newton's third law of motion. For every action force, there's an equal and opposite reaction force. And then once the ground has bumped the skateboard up into the air, then we look at rotational kinetic energy, and we conserve that energy by pushing down on the nose. The tail comes up to level the skateboard out. And then, of course, well, I guess if you want some more physics, it's Newton's first law of motion, isn't it? You would stay horizontal above the ground, except that gravity's a resultant force and accelerates the skateboard and the skater back down to the ground. So that's Newton's first law of motion. So we have the third law, we have rotational kinetic energy, and we have the first law. Actually, what we could go into talking about is the second law as well. If a force is acting on an object, the greater the force, the greater the acceleration of that object. And how this comes into play in terms of doing an Ollie, if you shove the skateboard down into the ground harder, it will go higher. So you can do a small Ollie, a big Ollie, depending on what you need to clear to get over. So there you go, the physics of doing an Ollie.